I've written a program that will allow me to demonstrate the answers to the first quiz that you took. And I'll give you a copy of this program, and my expectation is that you'll study it in great detail so that come Monday you'll be in a better position to perform well on the next quiz. So the answer to the questions, most of the questions on the quiz are contained in this program, and I've also gone a little beyond that. I've done some things that aren't really on the quiz, but I want to show you and talk about at the same time. So it's in part a quiz review and in part a lecture to go over just a little bit of new material. So question number 1 on the quiz reads, declare a class level variable of type int named val1 and initialize it to 0. So as I am looking at this project in the designer view, if I double click on the form, just on the open form, not on any of the control objects, but on the open form, it will transition to the code window, and the place to create class level variables is near the top of the program. Now there is no absolute requirement to put it here, but if you get used to doing this, then you'll know where to look, and anyone that might want to look at this program and maintain this program over time would certainly find this convenient. So what we have from the very top are using statements that get written for you, and we'll talk about using statements at some point in the future, but these are basically references to very specific places in the .NET class library where your program will be accessing some pre-written code. There is a class header. Okay, again, that's going to get written for you, and it's really beyond this left brace that you can begin inserting program code of your own. And beyond this first brace is a special startup method called a constructor. And again, this is a topic for a later date, but this gets pre-written for you, and this basically initializes the form object when the program first starts up. Okay, it's known as a constructor, and because this has a special purpose, I would go ahead and not introduce any code above this point right here. So you'll notice that I've inserted a comment statement and indicate that what follows are class level variables, and I have 3 class level variables that I've declared. One that was supposed to be done for question number 1, and so you're asked to create a class level variable named val1 of integer data type and initialize it to 0. So the declaration begins with the keyword private. Private means that the lifetime and scope of this object is going to be extended throughout the class and for the lifetime of the class. So any class level variable that you create, you want to begin it with the keyword private. Then you, in the usual way of declaring a variable, specify the data type, specify the name, and it is optional then that you can assign it some starting value. So in this case, I have chosen that option and assigned it, assignment operator, assigned it an initial value of 0. Question number 2, I'm going to flip over here to the designer window. Question number 2 reads, using the variable that you declared in question number 1, that would be val1, the class level integer variable val1, write the code for a method that will increment val1 by 1 if val1 has a value less than 5. If val1 has a value greater than 5, have the method increment val1 by 2. So there's 2 ways that you should increment this variable. You should increment it by 1 if our class level variable has a value less than 5, and if it has a value greater than or equal to 5, then you should increment it by 2. So this is a situation where a two-way decision structure is appropriate. And if I look at the program code behind the click event method, you'll see that I have in fact used a two-way decision structure. I'm also using the variable that was previously created up here, val1. And in the two-way decision structure, I check for the first case, which would be the variable contains a value less than 5. And if that is the case, I increment it by 1 using the shortcut incremental operator ++. And then what I show you in the assignment statement is that there are 2 other ways that I can accomplish that. The more traditional way of specifying val1 on the left side of the assignment statement, and then referencing it again in the expression where I add 1 to it. So an assignment statement will always evaluate the expression, resolve the expression, and assign the resulting value to whatever the target location is on the left. So I can use that target location in the expression because its current value will be included in the operation, and then once that new derived value occurs, the new derived value will be assigned to the variable. And then the other way I can do this is using a incremental operator +=, and this one is pretty handy because if I need to increment by any value, I can use the += operator. So I could say, for instance, +=2 or +=3, and that would take whatever the current contents of the variable is and bump it up by that amount. All right, so the two-way decision structure begins with a test to see whether val1 is less than 5. If it is, it's going to bump val1's value up by 1. If it is not true, if that evaluates false, then this path, this block, is ignored, and the else block or the else path is taken, in which case val1 is incremented by 2. And then, although this wasn't part of what I told you to do on the quiz, I went ahead and assigned the result to the title bar so that when you run this program, you can click on this and the output is 1, 2, 3, 4. You'll make note here, I'm currently at 4 after 4 clicks. And when I click 5, it bumps up one last time. Now, val1 has a value of 5 or greater at this point, so my next value should be 7, 9. From that point on, it begins to bump it up by 2. Okay, so I'm going to stop the program here and move on to question 3. Question 3 says write the code needed to move picture box 1 on top of picture box 2. So if we look at the designer window, I have picture box 1 and picture box 2. Now, I've decided to improve this a little bit. So my program is going to do everything that is required to answer the quiz question, plus it's going to do a little bit more. It's going to, when the program first starts up, it's going to assign to 2 class level variables being xq3 and yq3. Okay, so it's going to create 2 class level variables, and then whenever the program starts up, it will automatically run a method called form load. So if you choose to use the form load event method, it will automatically execute this method and whatever code is contained in the method before you, the user, have access to any of the control objects on the form. So this is a startup method, and what I'm having it do is assign the underlying x coordinate value of the form where picture box 1 is located to my integer class level variable xq3, and the underlying form's y coordinate value to a variable called yq3. So I had mentioned this in class. This corner point right up here, the xy coordinates here, are what I'm storing in the form load event, and yq3 is going to be the underlying form's y value, and xq3 is going to be the underlying form's x value at this point right here. Okay, so let me go back to this again. So we have these two class level variables, and I'm going to store away the value, the xy coordinates, where picture box 1 resides, because later on I'm going to move picture box 1 to the location of picture box 2, then give the user the option to move picture box 1 back to where it was originally, and these two variables are going to tell me where to place picture box 1 when I move it back to its original location. So I'm saving its original coordinates in these two integer variables. Now the other thing I want to tell you, and this crossed my mind as I was talking, is that if you want to access the form load event, you do that by, from the designer window, double clicking on the open form, and that will take you to the form load event. Okay, so if you don't click on any of the controls but click on the form itself, it'll take you to the form load event, that special startup method that if you use it will execute code as soon as all the forms have been put on, as soon as all the control objects have been put on the form. So let's take a look and see how this behaves. If I run it, it's going to look like this. Notice that this is going to have some characteristics, some of the same characteristics of the light switch program that we looked at. So question starts out with the text on the button face that was assigned to it in design view. It's going to say question 3 go, and if I click, it causes the picture box to go to from picture box 1's location to picture box 2's location, and the button face toggles to return, and if I click it, it toggles back to go when it puts this thing back to its original location. So go, return, go, return, go, return. And again, it has some of the same logical characteristics as the light switch program, so you can study those details. Okay, so I'm applying that same logic in a slightly different way. The other thing I do in here is I decide which way to go, so I'm using a two-way decision structure. Either I'm going to go or I'm going to return. So the easy way to deal with this is a single two-way decision structure. And I check the button face itself to see what it says, and if it says go, I send it to the location of picture box 2 through this assignment statement, and then I change the button face immediately. And this third line of code was necessary because even though I was moving picture box 1 to picture box 2's location, picture box 2 was overlaying it, and these control objects have a built-in method called bring to front. And what bring to front does is if you have a picture box or some other control object on top of some other control object, whatever control object you specify in the method, it will bring that one into view, put it on top so that it's visible. The bring to front method. Okay. So again, if it says go, you assign picture box 1's the same location as picture box 2, change the button face and make it visible. Otherwise, if it doesn't say go, then it must say return, because there's only two possible states that it toggles between. And in that case, if you're to return, it's going to set the left property of picture box 1 to the value that was stored in XQ3 in the form load event, and likewise the Y property is going to be stored in top, so left corresponds with X and the underlying form, and top corresponds with the Y coordinate of the underlying form, and then I changed the button face. Okay, so hopefully that's clear. Number 4, assume text box 1 stores an integer. Write a method that will examine the contents of text box 1 and display one of the following messages through a message box. And the message box should store one of 3 things: either negative if the value from the text box is less than 0, 0 if the value in the text box is 0, positive if the value in the text box is converted to an integer that is greater than 0. So let me go back to the design window. This is question 4. And what I did here was I created a integer variable in order to store the converted value from the text box, and because there could be the potential for user error, a value could be entered into the text box that will not convert to an integer, I wrap everything up in try catch. Okay, so I'm using try catch, and we've seen how that works before, that when this method execute, it will always favor and attempt to perform whatever is specified in the try block, and if everything goes okay, there aren't any runtime errors, runtime exceptions, then it will ignore the catch block. It'll do what's in the try block and then go to whatever is beyond this brace point right here. On the other hand, if anything goes wrong, if it does throw an exception, then it's going to roll back out of the try block. Anything that was done will be undone, and then it's going to take the catch path instead. And I had mentioned previously that there are sort of a logical similarity between try catch and a two-way decision structure. So if you understand how the if-else statement works, try catch should be pretty straightforward. And so within the try block, after declaring this variable and not really assigning anything to it, within the try block, I attempt to convert what's in text box 1 to integer and store it in my int variable inval. If that works out, then it's going to evaluate that numeric value. I'm not evaluating the text box value, but rather I'm evaluating the value that's derived from the text box that's stored in the integer numeric format in variable inval. So I evaluate inval, and if it's less than 0, so that's a numeric comparison there. 0 is numeric, inval is numeric. It compares them, and if it's less than 0, it's going to fire off a message box that says negative. Likewise, same variable is tested to see if it's equal to 0, fires off a message box accordingly. Then in a third and completely independent structure, it checks to see whether inval has a value greater than or equal to 0. So what I'm using are 3, count them, 1, 2, 3 mutually exclusive one-way decision structures that are arranged in sequence. Mutually exclusive because if it evaluates true for one of these, it will evaluate false for the other 2. So the 3 independent one-way decision structures are wrapped up in a try block, and I evaluate the numeric equivalent of what's in the text box, not the text box itself. So a lot of people evaluated text box at something like textbox1.text less than 0. Okay, well, you'd be comparing a string to an integer in that case, and what you need to do is convert text box to an integer, and then you can compare integer to integer. Okay, otherwise it's apples to oranges. All right, so that is question number 4. If I go back to the design window, question number 4, if I put in something, run this just for completeness, and if I run this and put in a -2 and click, it comes back and tells me it's negative. If I put in a 0, it comes back and tells me 0. If I put in a 1, it comes back and tells me positive. And that would be what you would expect. All right, so number 4 is done. Number 5, what value will be stored in val1 if the following method is executed 5 times? Okay, so we look at number 5. Here's the code behind it exactly as it was given. There is a declaration of a local variable named val1, and it is initialized to 0. That local variable will have a lifetime that spans for the lifetime of the method. When this method ends at that closing brace, that variable is gone forevermore. So every time you click this button, it's going to create a new variable val1. It's going to initialize it to 0. It's going to bump it up by 2 and display its current value. And when it does, let me do an undo here. And when it does, it will always be displaying 2. So if I run the program, oops, yeah, there it is, 2. I click it again, 2. I can click it as many times as I want to because it's creating a new variable and initializing it to 0. Step 1, and step 2, it bumps it up by 2. Step 3, it displays it, and it's always going to display 2. Okay. Question 6 is list and label the flowchart symbols shown in class. You should have that in your notes, and there are 6 of them, and we'd be looking at the oval, which is the terminal symbol that'll be labeled start and stop. Be applied 2 places. At the beginning of the process, it'll be used and labeled start. At the very end of the process, it'll be used and labeled stop. A second symbol would be a flow line, and they can be in the direction of left, right, up, and down, and they're used to connect one step to the next in the process. Another symbol that's used is a parallelogram, which indicates either input or output. A 5th symbol, I think I'm at 5, another symbol that's used would be a rectangle, which is a process. It roughly corresponds with an assignment statement if we apply this to programming. And then there's the diamond, which is the decision symbol, and it will always have one flow line leading in, 2 flow lines leading out, and the flow lines leading out, one will be labeled true, the other will be labeled false, and at that decision point, a Boolean expression will be evaluated, and it will evaluate either true or false. And then the final flowchart symbol is a circle known as a connector, and it's usually labeled, its first occurrence, it'll be labeled A, second occurrence B, and it's used to show where to resume the process should you physically run out of space in drawing the diagram. Question 7 lists 3 flow of control structures found in all imperative programming languages. Memorize it. Sequence. One statement executes after another. That's the default flow of control. Decision. And we've looked at one-way decision logic, two-way decision logic. There's still more to be covered, but in the event that we reach a point in the process where we need to branch, we can evaluate a true-false expression and decide whether to go one way or another. And then a third flow of control structure that's used in all programming languages is one that we haven't seen yet, but that we will shortly. It's called iteration, or sometimes called looping, and we'll be looking at a couple of different loops, the while loop and the for loop. Number 8, how does syntax error differ from a logic error? This has been asked before. So syntax error is a error that occurs when a program statement is not written correctly and therefore cannot be translated into its binary instruction by the language translator, by the compiler, or the interpreter. And a logic error occurs when the algorithm or the blueprint, the logic blueprint, the step-by-step outline of the logic that's needed to solve the problem, is a error that results from a faulty algorithm. Number 9, two things that make up an object are methods and properties. And 10, write the code to create an instance of the Form1 class and display it. So in my project here, I have question number 10, and I actually use Form2 instead of Form1. But the first line of code will create an object named OBJNextForm of type Form2, and then I actually create an instance of the Form2 class. The object's actually created here. So I declare the variable that I'm going to use for the object here, and I actually instantiate or create the object here. And I'm doing two things at once. Later on you'll see examples where we may create our object variable or declare our object variable and then wait until later on in the program to actually do the second part to transform it into an object, to instantiate the class. But I'm doing both of those in one step here. So beyond this point, an object will exist, an object named OBJNextForm, and so on the next line I can invoke the object's show method, and that has the effect of letting me transition to the next form. So there you have it. If I click, it takes me to Form2. Do that all day long if you like. Okay, that's a wrap on the answer to the quiz questions, and I will post this on YouTube sometime later on this afternoon, and I would suggest that you study this very, very completely, because again, I'll be giving a quiz on Monday, and I'm expecting you to do well on it.